My dear students, today's topic of lecture is inverse trigonometry. So for starting the inverse trigonometry, let us start some basic concept of the function. So we know that we have six trigonometric functions. Six trigonometric functions. These are sine function, cosine function, tangent function, cotangent function, sec function, cosec function. So these are the six trigonometric functions. All have a different domain and range. For finding the inverse of each trigonometric functions, we should have to restrict their domain in some particular branches. So if I restrict the domains in some branches, then they will become 1, 1, 1, 2. For every 1, 1, 1, 2 functions should have inverse. So let us discuss some basic concept of the sine function. We know that sine function function has the domain set of R, and its codomain is -1 and 1. So -1 and 1 range, you know that range is the set of all real numbers starting from -infinite to plus infinite. If I give the values from the set of R from -infinite to plus infinite, the sine functions have the values lies between -1 and 1. Lies between -1 and 1. So R is called its a domain. First function is called by the definition of the function known as domain, and -1 and 1, this interval known as the codomain. This is known as the codomain. So here, so let us give some examples. We know that sine 0 degree has 0 value. Sine 90 pi by 2 radians has value +1. Sine 3 pi by 2. Sine 3 pi by 2 has the value of -1. So all values of the sine, if I take the elements from the domains, it includes between -1 and 1. So -1 and 1 also part of the range. So every range of this one, we can write the domain of the sine function in the set builder format. X such that x lies values from -infinite to plus infinite. This is the domain of the sine functions. So let us discuss. Suppose y is equal to sine x. So here x belongs to the domain of the sine function. Domain of the sine function is R, and this y should belong to -1 to +1. So also we can say that sine x belong to -1 and 1. So our range of sine x will be here y such that y lies between -1 and 1. -1 and 1 is the range of the sine function. Since the sine functions has, we know that sine pi by 2 is 1, sine 3 pi by 2 is -1, and we know that sine has multiples at multiple real points, its value is 1. So sine 0 degree is 0, and we also know that sine pi is also 0, sine 2 pi is equal to 0. So sine function, these sine functions, if the domain is R, it will not be 1, 1, 1, 2 function. For becoming 1, 1, 1, 2, we have to restrict the domain of R in some particular branches. There are many branches of the sine functions. On these branches, these sine functions become 1, 1, 1, 2. It is necessary if the functions we have, if to calculate the inverse of sine functions, we have to restrict the domains of R in some branches. So some branches, these branches we will talk later when we discuss the inverse functions. So that's why this function is not 1 1 1 2. It is many one type of functions. Many sine functions are the many one type of functions. If the domain is of set of R, many one into function. It is not onto function. It is many one into functions. So we have to change the domain of set of R. So next function, so we have cos function. Cos functions are also not 1 on 1 2 functions. Now it is written as its domain is also R, and its codomains -1. Codomain set is -1 to 1. Same thing would happen for its range and range functions also this ones. So its range of the sine function is y such that y should have the values contained from -1 to +1. From -1 to +1, it's the range values of this one. And it's this is the codomain ones. Domain, not this is domain, this is codomain. Domain of the cos functions will be x such that set builder formats x belong to set of real number. Here set of real number take the values from -infinite to +infinite. So all values of the real numbers including from -infinite to +infinite will be the part of the domain. Another important thing is range is always subset of the codomain. So here range in all functions, range should be the subset of codomain. So range always subset of the codomain. And next function, so we have tan function, tangent function, cot function, secant and cosecant. All have different domain and range. Let us discuss. Next one is a tangent function. Its domain is from the set of R, set of real number. Sine function is not defined for some particular values. We know that sine 10x is good, not sine, it is 10x. Sine x upon cos x. If the cos x becomes some values of set of real numbers, 10x is not defined. 10x not defined means 10x has the value some infinite values. So cos x will be 0. Cos x will be 0 for values of x lies in the intervals. In the set of a real number, there are many points where cos x will be 0 at plus minus pi by 2, plus pi by 2, minus pi by 2, and similarly plus minus 3 pi by 2, and so on. It means that cos x will be 0. If cos x will be 0, something is 0 in the denominators, so our value becomes infinite. So something, suppose 1 upon 0 is infinite, so those values of these values from these values, if I put these values in these functions, so it becomes not defined. It comes out the values plus minus infinite. So plus minus infinite we have to exclude from the domain from the set of real number. So our domain of the 10x will be R minus. So if I generalize this ones, if I generalize value, I have to put the generalized values x such that x is equal to odd multiples of pi by 2. So odd multiple of pi by 2 will be 3n plus 1 multiplications pi by 2. So this is the domain part of the tangent function, and its codomain will be so 10 has values minus infinite to plus infinite, all values. Its values comes out all values. The set of R is the domain of the tangent functions. So it means that if I draw the graph of the tangent functions, So it contains the codomains will contains elements, real numbers from minus infinite to plus infinite. So only these value, for these values, the values of tangent has the values of plus minus infinite, because 10x is equal to sine x upon cos x. So those values of x for which the angles is plus minus pi by 2 plus minus 3 pi by 2. Our cos x becomes 0, something is 0 in the denominator, the value comes out infinite, plus minus infinite, somewhere plus infinite, somewhere minus infinite. So that's why we have deleted from the set of real numbers these numbers, these angles, and our domain becomes R. Next one is a cotangent function. Now chord function, cotangent means chord functions. Chord functions have domain. Same thing would happens for the cos function, so chord functions also. Now chord function, we know that cot x is equal to cos by sine, cos x divided by sine x. So we have it is not defined, so where sine x equal to 0, sine x will equal to 0 for the angles of 0, pi, 2 pi, 3 pi, and for the negative side it is minus pi, minus 2 pi, minus 3 pi, etc. So sine x will be 0 for the angles 0, plus minus pi, plus minus 2 pi, and so on. So for these values the denominator becomes 0, and something is 0 in the denominator, it will become plus minus infinite. So cot x value plus minus infinite, plus minus infinite if the real numbers, then it is called not defined. So not defined, the cot x in these values is not defined. Cot x becomes plus infinite, also minus infinite. So we can say that it is not defined for these angles. Not defined for the angles which is 0 and plus minus pi, plus minus 2 pi, and so on. So we have to uh, remove from the set of real numbers these angles. So it's a domain of the chord functions will be from the set of real numbers. These number in the set builder format, it has the value x such that x is equal to n pi, and here the integer, and will be the integers, integer and domain also, codomains also set of real numbers. So chord has the values from minus infinite to plus infinite, set of real number, and also here n should belong to set of integer. So here R is the set of real number, set of real number. So set of real numbers, it includes the value from minus infinite to plus infinite. All real numbers from minus infinite to plus infinite will be the part of the domain. Domain of the will be the set of real number. And from the set of real numbers, if I remove these angles 0, plus minus pi, plus minus 2 pi, and so on, so we get the domain of the chord functions. So next ones we have to define sec function. For the sec function, so next we have a secant function. This is tangent function, the domain and codomain of the tangent function. And this part is a cotangent. Cotangent function. And this is the sine function. So next one we have a secant function. Secant functions or sec. Now it's a domain. It is also not defined for the all real numbers. So we have to exclude some element from the set of real numbers. So we know that sec x is equal to 1 upon cos x. So sec x is not defined for which cos x has the value of 0. So if cos x is equal to 0, then sec x will be plus minus infinite. So cos x will be 0 if the angles of the cos function is uh, multiplications, odd multiplication of pi by 2. It means that 1 pi by 2, ठीक है, और plus minus pi by 2, plus minus 3 pi by 2, plus minus 5 pi by 2. So and so on. There are many infinite numbers in the set of real numbers. So for these values, sec x becomes not defined, means something upon 0. Something upon 0, it becomes infinite. It can have also plus minus infinite. So some values, that value becomes minus infinite. So we have to remove these angles from the set of therefore in set builder formats we have x such that x will be 2n plus 1 pi by 2. Here n belong to set of integer and curly bracket, and its domain will be now this is the domain and it's a codomain. Codomain of a secant function is it's a domain and codomains from the set of R. Exclude the values. It will not have the value minus 1 to 1. Sec has no values which lies between minus 1 to 1, and also sec x values plus 1. It has value plus 1 and minus 1. That's why minus 1 and 1 is not include this one. Open intervals at minus 1 and plus 1. So it is not defined for values plus minus pi by 2, plus minus 3 pi by 2, and so on, for which it values of sec x become plus minus infinite, which is not defined. It is called not defined for these angles. So sec x not defined for these angles. So we have exclude from this one. So here this is the domain part and this is the codomain part. Next one, so we have a cosecant function. Cosecant function, also called sec function. Cosec, its domains is also not the whole set of real numbers. We have to exclude some real numbers from the set of real numbers. These will be cos x is equal to 1 upon sin x. So sin x is not defined at angles 0, plus minus 5, plus minus 2 pi, and so on. So we have to exclude these from the set of real numbers. And pi, here n is the set of integer and this is the domain part, and its codomains will be set of real numbers. We have to remove this interval, this open interval minus 1 to plus 1 from the सेट ऑफ रियल नंबर. सो बिकॉज ऐसा इसलिए होता है कि हमने यहां से इसको रिमूव कर दिया, बिकॉज cosec x is equal to 1 upon sin x. तो cosec x is equal to 1 upon sin x. So sin x will be 0 for the angles which is the 0 plus minus pi plus minus 2 pi etc. So sin x here, sin x will be 0. So for the angles 0 and plus minus pi plus minus 2 pi and so on. For these angles the denominators will be 0, then cos x will be plus minus infinite, so which is not the real numbers, and also we say that this is not defined. So that's why these are the some basic concept of the six trigonometric functions, and these all are not one two function. These all are many one into type of functions. So next we have to discuss one by one inverse of these six trigonometric functions, and if we restrict the domain of these trigonometric functions for some intervals, then it becomes 1 onto. For every 1 onto functions there would be inverse, and if the function is 1 onto, their inverse is also 1 onto. Let us discuss next function. So we have the sine functions, and then we go in by series sine, cosines, tangent, cotangent, secant and cosecant functions one by one.